Okay, the next item that we're talking about in today's lesson has to do with angles that are formed when I draw a transversal through two lines. Well, let's make sure that we're clear on the vocabulary. Looking at this diagram, lines A and B are my lines. Lines A and B are my lines, and I say that line T is my transversal. The transversal, then, is a line that's doing what? What do you think? So, intersects two lines is a big part of it. Another big part of it is that it's intersecting those two lines at two different places. Okay, so a transversal is a line that intersects two. I hate when it does that. Two or more other lines at distinct points. Okay, so in this diagram, there will be four kinds of special angle pairs that we will discuss. Let's first number these angles so we have something to refer to. So make sure that you're numbering your angles the way I've numbered mine, otherwise our descriptions won't match up and you'll end up studying from the wrong thing. So the first kind of special angle pair that I have up here is alternate interior angles. And I want you to get to the point where the names of these special angle pairs kind of give away where the angles are. So just based on the name, Eugene, you have a hunch?
5 and 4.
Angles 5 and 4 will be alternate interior angles. And now that he's identified them for us.
With the definition, I'm not really getting that. Two or more other lines at distinct points.
Okay,
You forgot to put it in text.
Oh my gosh, thank you. Thank you, Michael. Does that help?
Yeah.
Sorry about that. All right, so alternate interior angles, like angles 5 and 4, how would we describe those angles? If you were talking to one of the students that's absent today, and you wanted to describe to them, hey, these angles are alternate interior angles because, I'd like to hear from someone different. Anyone have a way to communicate that to a friend? How would you describe them to a friend?
It's the angles on opposite sides of the line
Which line?
of the transversal
Good.
that form the outside or the inside angle, the closest to the line.
That are inside of the
other
two
side,
lines.
okay.
Yes. Okay, so alternate interior angles are, as she said, angles. You know what? I'm going to type this just so that it fits. They're angles on opposite sides of the transversal inside of the two lines.
They also had a 180, correct?
And you're getting ahead. And not necessarily. No. Not that you're mixing up your properties. Okay.
Wouldn't they also be 3 and 6?
Excellent. Yes, angles 3 and 6 would also be alternate interior angles. Adrian.
That's what I was going to ask. But, so it couldn't be like 3 and 5 though, because they're on the same side of the line.
Look at what you just said. Think about what you just said. And glance at the screen. Tell me about angles 3 and 5. No.
They're same side interior.
They're going to be same side interior angles. So since you brought it up, let's go there. Sure. Same side interior angles would be like angles 3 and 5. And once again, if you had to describe these angles to a buddy that isn't here today, how might you describe them? Helena.
Angles on the same side of the transversal and sides into a line.
Yes. And in the interest of thoroughness, there's another pair of same side interior angles in this diagram. What are they, Sarah?
4 and 6.
Angles 4 and 6. All right. The next pair of special angles that are formed by two lines cut by a transversal, alternate exterior angles. And again, just by the name, I'd like you to be able to identify them. I'm hearing a lot. Love hearing from Sarah, but I'd love to hear from more of you. I know it's morning. It's morning for me too. Zoe.
Angle 8 and angle 2.
Be careful. Alternate exterior angles. Angles 8 and 1, yes, are alternate exterior angles. And again, I don't want to cut the diagram out. If you had to communicate this to a friend, how would you describe those alternate exterior angles? How would you describe these alternate exterior angles? Matthew?
Angles on the opposite side of the transversal and outside of the two lines.
Precisely, yes. And I'll tell you, for some reason, corresponding angles tend to be the one that students have the most difficulty with because the name doesn't really give it away. Okay? So I will tell you, angles 1 and 5 are corresponding angles. Angles 1 and 5 are corresponding angles. Okay.
Is it because that they're above the line?
They're both above the line, yes. However, notice also the angles 4 and 8 would also be corresponding angles. Sarah?
It's the angle on the same spot as
So one of the, I think the way that your book describes it is that they're in corresponding positions with respect to the two lines. That's kind of using the word to define the word, and I hate that. But there's really no other nice, compact, succinct way to say it. If I wanted to be really, really elaborate and try to make it as clear as possible, it would take a moment. So let's backtrack first of all. We talked about alternate interior and exterior angles, and we talked about same side interior angles, and so those gave us a clue about where the angles were with respect to the transversal. Tell me something about these angles as far as the transversal goes. Are they on the same side of the transversal, or are they on opposite sides of the transversal? Okay, so that's an important part of how we describe these angles, that they are on the same side, bless you, side of the transversal. Thank you. And then if I wanted to be as elaborate and thorough as possible, I might say both either above the two lines or both below the two lines. And I know that takes up perhaps quite a bit more space than you have there, but that's as absolutely clear as I can make that. I don't like using the word corresponding to define corresponding angles. But you will see that in your textbook, that they describe the angles as being in corresponding position with respect to the two lines. Adrian?
So it's basically like one is interior and one is exterior.
Yes, always. Good. Okay. Any other questions about these 4 angle pairs? Okay. Let's move on to identifying them. Do we have from this screen what we need? I know there was a lot here. So yesterday we talked about the special angles that are formed when 2 lines are cut by a transversal. Today we're going to be specifically talking about what happens when those 2 lines that are being cut by a transversal are parallel. So let's consider this little construct I've made. So in this diagram on the screen, I have parallel lines being cut by a transversal. And for the purpose of good practice, can someone please name for me a pair of corresponding angles in this diagram? A pair of corresponding angles in this diagram. Sarah. Well, remember, you want to make sure that you're using 3 letters, because there's a lot of angles in here, a lot of possibility for confusion. So naming the angles using 3 letters. GIF is a straight angle. What I'm asking for is a pair of corresponding angles, like the angles we discussed yesterday. Do you want to pass that baton? Yeah. Okay. Someone else, please. A pair of corresponding angles out of this diagram, being careful to name your angles using 3 letters. Yes, Catherine. DBI and GIH. Yes, those are a pair of corresponding angles. Someone else, please. A pair of alternate interior angles. Someone else, please. A pair of alternate interior angles. We talked about this yesterday. They're going to be on opposite sides of the transversal, inside of the 2 lines. I know we're having to name it with 3 letters, but you've got to be able to do that also. Yes?
BIF and DBI.
BIF. And what was the other one? DBI. Yes. A pair of alternate exterior angles, please. Someone else. A pair of alternate exterior angles. Remember from yesterday's lesson, they're going to be on opposite sides of the transversal, outside of the 2 lines. Stephanie? ABD.
FIH.
And FIH, absolutely, yes. And perhaps you're already making some observations. Finally, though, let's get some same side interior angles up here. Remember, those are on the same side of the transversal, inside the 2 lines. Does that pass over? Never mind. So I'd like to hear from different people. No? Mariah, please. FIB. Absolutely, CBI. Fantastic. And you're possibly looking at these angle measures and saying, oh, this looks interesting, but Mrs. Clouse, maybe you kind of jury-rigged that so that it looks that way. Let's test that out. Did I kind of trick you and make this happen? Or is it always like this? Notice the angle measures are changing.
Okay, that's really fun.
But what do you notice about the corresponding angles? Even as the measures were changing, the 2 corresponding angles
Still corresponding.
were always what?
Corresponding.
Oh, wait.
You're thinking the wrong C word there. Congruent, yes. How about alternate interior angles? They're congruent. How about alternate exterior angles? Congruent. And same side interior angles? No. So any thoughts on those same side interior angles? Because they're not congruent, but there is in fact something special about them. Do you notice anything about them, Catherine? They are supplementary. So in our notes, We know exactly how we're filling in these blanks now. That if two parallel lines are cut by a transversal, then the corresponding angles are congruent, and the alternate interior angles are congruent, and the alternate exterior angles are congruent. Same side interior angles are your odd man out, and they are supplementary. And once again, in our notes, in my attempt to make my lessons as transparent as possible so that you know exactly what's expected of you, the knowledge of these properties is where you are at level 2. Where you want to be, remember, is at level 3, being able to do something with these properties. And what we will be doing with these properties is using them to find angle measures and complete proofs. Oh, I heard that. Let's ease into that. Starting with problem 1, finding which angles in this diagram measure 130 degrees. So what angle do you see, Kristen? One angle, please.
5.
Angle 5. Daria, give me another, please.
Angle 2.
Angle 2 is another, and there is one more. Someone else, please. Hope.
Angle 4.
Angle 4. And I know this isn't asked of us in this problem, but like I said, I want to kind of ease into the idea of doing these proofs and using these properties to complete proofs. So let's talk about why angle 2, for example, is 130 degrees. And what I'm asking you first and foremost is to look at the relationship between angle 2 and the 130 degree angle that they gave us. Stephanie. They're alternate interior angles. So our reason, therefore, is the alternate interior angle theorem. Going in order and moving on to angle 4, again my question, why do I know that angle 4 will also be 130 degrees? Again, you're looking just at angle 4 and the 130 degree angle that they gave you. What do you notice about them? The angle 4 and the 130 degree angle, Michael. They're vertical angles, so my reason would be the vertical angle theorem. Finally, if I was just looking at angle 5 and the 130 degree angle given, why am I allowed to conclude that angle 5 is also 130 degrees? Someone else, please. Why am I allowed to conclude that angle 5 is 130, comparing it just to the 130 that was given to us? Kate?
Alternate exterior.
They are not. I'm looking at the 5 and the 130. They are corresponding. Now, if you're looking at angle 5 and 4, you would be right. Those are alternate exterior angles. I do, however, want to be comparing it to the original angle. So this is the corresponding angles postulate. Should I write out of space? And I'm hearing it. Oh my goodness. How am I going to remember which one is a theorem and which one is postulate? Don't worry about it. Don't worry about it. On a test, if you write theorem instead of postulate, that's not what I'm going to ding you for. What's important to me is that you know which pair of angles they are. On the EOC, they're not going to have corresponding angles postulate and corresponding angles theorem as two separate choices for a reason and a proof. They're not going to do that. That's not what's important to them either. What's important is that you can identify them as, in fact, corresponding angles. Okay, good on this screen. All right. On to the fun stuff. Everybody's favorite thing in the whole wide world. Nobody should have gotten 0 points for the proof on Wednesday's test, because you always know the given. You should have gotten at least those 2 points. So that's where we start. We start with A parallel to B. Remember, that's what that symbol means. The two lines are indicating that A and B are parallel. Oops. Also, I wanted to indicate on this screen, you're used to seeing arrowheads at the end of the line to indicate that it is a line and that it is going on forever. What I want to call your attention to, however, is these extra arrowheads that you see kind of in the middle of the line. Understand that that's how the book indicates parallel lines. So you'll see them indicated in red in your textbook. So when you see them, understand what they mean. The arrowheads indicate parallel lines. Don't confuse that with hash marks that indicate congruent segments. Be careful of the difference. Okay, so you might want to make a note to yourself that this means parallel. So I'm given that two lines are parallel, and I'm being asked to prove that two angles are supplementary. So somehow I've got to bring these angles into the proof so that I can move and shape them into eventually saying that angle 1 and angle 3 are supplementary. Any thoughts on how we're going to do that? We need to bring these angles into the proof. What can I say about these angles, Mariah?
Would you just have a supplement where it would be angle 1 is
What is angle 1 congruent to?
angle 3?
Angle 1 is not congruent to angle 3. Be careful. Angle 1 is congruent to angle 2. And I've kind of given away the statement. Make sure that you understand why, though. Why is angle 1 congruent to angle 2? Look at them in the diagram. Stephanie.
Because they're all
Precisely. So the property that we're using is the alternate exterior angle theorem. And that's one of the beautiful things about a lot of these properties, that don't panic of, oh, there's so many properties and how am I going to remember them all? A lot of the properties are just the same name as the angles that we're talking about with them. Okay, so I brought angles 1 and 2 into the picture. If angle 1 is congruent to angle 2, does that give me something else that I can say that'll eventually get me closer to saying that angles 1 and 3 are supplementary? Or you can't quite think of what to do with it right now? Let's table angles 1 and 3 for right now. Looking at the diagram, I still have to somehow say something about angle 3. I need to bring angle 3 into the picture. So, I can't tell if that's your hand. Yes. Angle 2 is not a corresponding angle to a labeled angle in the diagram. No.
Oh, I thought it was angle 1 and 3. Sorry.
No, no.
It is angle 3.
No, I can't make that assumption either. And ladies and gentlemen, this is an angle relationship that some of us are still struggling with in here. Maddie, what do you see?
angle 2 and angle 3 are same side of him.
No, but they are something. Angle 2, let's say this. Measure of angle 2 plus measure of angle 3 equals 180. Yes, do you have a reason?
Definition of a linear pair.
It's not the definition of a linear pair, but you're on the right track. It has to do with them being a linear pair. It's called the linear pair postulate. And that's one that you want to be careful with. Just like when we say that vertical angles are congruent, we're not using the definition of vertical angles. Definition of vertical angles only tells us what vertical angles look like, just like the definition of a linear pair only tells us what they look like. Yes. Yes. Okay, so now I have all of my angles, nice and together in the proof somehow, and I just want to get together the ones that are really important to me, which are angles 1 and 3. Any thoughts on how to get there?
Transit.
I think what you're aiming for is more substitution property. However, if we want to be really, really strict about the substitution property, it means that I can take something that equals another thing and substitute it into an equation. I don't have that these two things are equal to each other yet. I have that they're congruent. So let's say in statement 4 that the measure of angle 1 equals the measure of angle 2. And I've drawn that arrow there so that you realize where that statement is coming from. I went from saying that the angles are congruent to saying that their measures are equal. Why am I allowed to say that? What property, what definition tells me that if things are congruent, then their measures are equal? What's that sound like to you? It's the definition of congruence. And now I'm ready to use that substitution property that Maddie was wanting us to. I can take angle 1 and substitute it in for angle 2. That'll give me measure of angle 1 plus measure of angle 3 equaling 180. And now we're very, very close. We're almost there. Notice what we're saying and notice what we're being asked to prove. What we've said so far is that angles 1 and 3 add up to 180. What I want to prove is that they are supplementary. So my question to you, first of all, is, am I ready to make that statement? Can I go from saying that they add up to 180 to saying that they're supplementary in just one step? Can I do that? Yes. Why? Okay, but what is that? Is that a definition? Is it a property, a postulate, a theorem? It's the definition of supplementary, yes. And again, ladies and gentlemen, I realize that this doesn't come naturally for some of you. And that's to be expected. It's something totally new. You've never had to do this before. It takes time. The more you do them, I assure you, the easier it's intended to get. We're still getting from the screen what we need? Or we're good? Moving back to the front in order to catch problem 3. I apologize for this back and forth bit, but it was the only way that everything would fit on one piece of paper. In problem 3, kind of like in problem 1, this time we're finding angle measures, but again, I want to explain why the angle measures end up being what they are. If this isn't just popping out at you, and for some of you it might not, the strategy that you want to be employing is looking at the two angles, the angle that you're given and the angle that you're trying to find, looking at those two angles and asking yourself, what kind of angles are they? Are they one of our special angles? Are they possibly a previous angle relationship that we've talked about? Because those aren't going away, as you saw in this last proof. Linear pair, not going away. Vertical angles, sticking around. So in problem 3, looking at angle 8 and the 115-degree angle, my question to you, first of all, is what kind of angles are they? What kind of angles are they, Caitlin?
Same side.
They are same side interior, and since I know that they're same side interior, our property tells us that they do what? They're supplementary. So I know that the measure of angle 8 is what?
What?
It's 180 minus the 115 and 65. It's all right, it's Friday for me too. Okay, so our reason why this is 65 degrees are explained, we've already done when we identified these angles as same side interior.
I'm confused. How did you get 65 from? Because aren't 150? Because like, isn't like the 115 the same as the 80?
No. What you need to observe is that they are same side interior angles. Before I go any further, do you see that? That these two angles are on the same side of transversal N, and they are inside of lines A and B. Okay, so they're same side interior angles. And back here, the property that I gave you about same side interior angles is that they're supplementary.
Oh, so you just subtract 180 from.
Mhm.
Okay.
That's exactly what you do. Same line of thinking for angle 4. Don't just pop an answer out. Be able to explain yourself. Be able to communicate. What's the relationship between angle 4 and 115? I'd like to hear from someone different. Angle 4 and the 115 degree angle, what kind of angles are they? Patty.
Corresponding.
They are corresponding angles. And what do I know about corresponding angles? They're congruent. So I know that the measure of angle 4 is 115. Problem 4, look at together within your table. Because it's a little bit beefier.
Oh, jeez.
All right, I'm hearing some really great stuff. Hope.
I think, can I tell you what I think it is?
Please.
70 degrees.
It is 70 degrees. Now, I overheard you explaining it over there.
Me?
Yes, I did. It was wonderful.
Did I get to go up on the board?
Sure. Hit it.
Yes.
Oh my god.
Okay. I've never done this before.
You just don't want to lean with your hand. That's kind of the
Okay.
big mistake.
I explain it too, right?
Yeah, hit it.
Okay. So these two are parallel because the little arrow means it's parallel. So if this is a straight line, then these two angles have to both equal 50 degrees.
Label the other 50-degree angle that you're talking about, please.
Oh.
It's okay. Okay, so that's the angle she's referring to.
Those are both 50 degrees. And a straight angle equals 180, and this is the straight angle right here. And so 50 plus 60 equals 110. And 180 minus 110 is 70, and that's the remaining degrees.
That's it. Beautiful. Thank you very much. Okay, another way that you could have looked at it. Yes, y does equal 70. One other observation that you could have made is that if you look at this angle here and there, if you look at those two blue angles I've highlighted, they are same side interior angles. And they must add up to 180 degrees. So once again, you'd be figuring out what plus 60 plus 50 equals 180, and you'll still end up in the exact same place that Hope did. You'll end up with y equals 70. Question there. Okay, there is a daily quiz activated on Socrative. First of all, though, do please take a close look at that Your Turn problem 4. It's a little bit, and I want to make sure that you're actually looking at it and asking questions about it before you leave. But again, there is a daily quiz on Socrative. You do have enough time to do both.